So now we will talk about important formula of kinetic theory of gases. Each and every formula has been asked in the examination, so it becomes very important to remember all the formula. So first formula, that is for ideal gas equation, we know that for ideal gas equation we write PV is equal to nRT. Now this is pressure, volume, moles of gas, this is gas constant, and this is temperature. So this is ideal gas equation, PV is equal to nRT. Now if we modify this formula, that is volume, we can write volume is equal to mass upon density. So from here we can write P, instead of V we can write mass upon density. So mass upon density is equal to nRT. So we from here we can write Pm is equal to dRT into N. For 1 mole of gas we can write density of gas is equal to Pm upon RT. This formula is also very important, right? Another formula, density in terms of, another formula very important, directly it was asked in NEET examination. Density is equal to P into small m into kT. What is small m? Small m is mass of gas molecules, mass of gas molecules, and K is Boltzmann constant, and value of K is equal to 1.38 into 10 की power minus 23, and the unit will be kg meter square upon second square into Kelvin. This is the unit of K. K is the Boltzmann constant, right? And K can also be written as R upon Na, where Na is the Avogadro number, and R is the gas constant. The value of R will be given in the question, right? So this is very important formula, density of gas in terms of mass of each molecule, and K is the Boltzmann constant. Now you know that velocity, RMS velocity, formula for RMS velocity is equal to root under 3 RT upon molecular weight, and V RMS can also be written as root under 3 kT upon small m. Again, small m is mass of each gas molecule, and K is the Boltzmann constant, right? Now, so if we want to write pressure in terms of mass of each gas molecule, total number of molecule, and volume of gas, and RMS velocity, then pressure will be written as 1 by 3 small m into capital N upon capital V into V square RMS. Very important formula. This was asked in NEET examination, not once, twice, it was asked 3 times in the NEET examination. What is M? Again, M is mass of each gas molecule. What is N? What is N? N is total number of gas molecule. Total number of gas molecule. And what is V? Capital V, it is volume of gas. And what is V square RMS? It is RMS velocity, root mean square velocity, right? Now again a very important formula is average thermal energy can be given as F by 2 into K into T. What is F? F is degree of freedom, F is degree of freedom, and K is the Boltzmann constant, and T is the temperature, right? Degree of freedom for monoatomic gas will be 3, for diatomic gas will be 5, right? So very important, again average thermal energy will be F by 2 into kT. Now if we want to write the value of Cp will be F by 2 plus 1 into R. Formula for Cp is F by 2 plus 1 into R. Again F is degree of freedom. Formula for Cv will be F by 2 into R. Again F is degree of freedom, and gamma is equal to Cp upon Cv. These three formula is also very important. Now another important formula is internal energy of a gas. Internal energy of a gas. Internal energy of a gas. So internal energy is usually denoted by U, capital U, that will be F by 2 nRT. F by 2 nRT. Again F is degree of freedom, N is number of gas molecule, a mole, and R is gas constant, and T is temperature. Right? So N is mole of gas and F is degree of freedom. Now if we take a condition that is constant volume, condition is constant volume, this will be written in the question's language, that the question will say condition given is the constant volume. So at constant volume, amount of heat energy required, so amount of heat energy required, amount of heat energy required to raise the temperature of a gas, at constant volume, amount of heat energy required to raise the temperature of a gas, that is that heat energy delta Q can be given as NCV delta T. Very important formula. So at constant volume, amount of heat energy required to raise the temperature of a substance will be given as NCV delta T. What is N? What is N? N is number of mole of gas. Cv we can calculate by this formula, F by 2 into R, and T, delta T will be change in temperature. And again degree of freedom can be calculated as 2 upon gamma minus 1. Degree of freedom can be calculated as 2 upon gamma minus. This question was directly asked in this formula was directly asked in NEET examination. And again gamma is equal to Cp upon Cv. Right? Now one very important formula is mean free path of gas. Mean free path of a gas, mean free path. It is denoted by lambda, and lambda is equal to 1 upon root under 2 pi n d square. So from here we can say what is n? What is n? N is the number density. And what is d? D is the diameter of gas molecule. Diameter of gas molecule. So from here we can say lambda is inversely proportional to d square, and diameter can be written as 2r. So lambda will be inversely proportional to r square. Very important. So these were the formula, the important formula in kinetic theory of gases, which was directly asked in NEET examination. So it's very important for you to learn these formula. If let me give you a quick revision. Density in terms of pressure of gas, mass of each molecule, Boltzmann constant, and temperature. So density is equal to Pm upon KT. One density can be calculated as Pm upon RT, where m is the molecular weight of the gas, right? And PV is equal to nRT. This is the ideal gas equation. Average thermal energy can be written as F by 2 kT, where F is degree of freedom. For monoatomic gas, F is 3, diatomic F is 5. Cp can be calculated as F by 2 plus 1 into R, and Cv can be calculated as F by 2 into R. Gamma will be Cp by Cv. K is the Boltzmann constant, can be written as 1.38 into 10 to the power minus 23 kg meter square upon second square into Kelvin. K is equal to R upon Na, where R is gas constant, Na is the Avogadro number. Vrms can be calculated as root under 3 RT upon molecular weight, and Vrms can also be calculated as root under 3 kT upon small m. Again, what is m? Mass of each gas molecule. What is K? K is the Boltzmann constant. Pressure in terms of mass of gas molecule, N is the total number of gas molecule, and V is the volume of gas, and V square RMS, that is root mean square velocity. And internal energy of gas can be written as F by 2 nRT, where F is degree of freedom, N is mole of gas, R is gas constant, and T is temperature. And at constant volume, amount of heat energy required to raise the temperature of a gas can also be given as NCV delta T. N is mole of gas, and CV is equal to, again, F by 2 into R, and degree of freedom can be calculated as 2 upon gamma minus 1. Mean free path can be calculated as 1 upon root 2 pi n d square, where n is number density and d is diameter of gas molecule, and diameter can also be written as 2r.